All right. Yeah, I guess we can begin. I think there Bennett was supposed to, I guess, give a presentation on his CryptoSynth thing, um the NFT that he is selling. But I guess in the meantime, we can just, well, not in the meantime. I guess we can start with um the paper I had shared in the WhatsApp group earlier this week. I found it to be a very interesting paper. Let me see. Yeah, so this paper here. Yeah, so the title of the paper is Why AI is Harder Than We Think. I mean, instantly when I saw the headline, I was pretty much drawn to it. I saw some people discussing this on, was it Reddit? Yeah, and people had their different opinions on what she said. But I think she rose some very good points. I think we can discuss some of the things here. I mean, I think with any like future technology or predictions about future technology, there's always gonna be pessimists and optimists. So I guess by the end of this meeting, we can find out where either of us lies on that spectrum. So what I guess we can do is just go through what the paper says, um, look at the important points she makes, and then we can, I guess, uh, talk about what she said, or give her or assessment or opinion on what she said. So I'm gonna start with the abstract, and then we can basically, I guess, talk about what she, or basically discuss what the abstract is saying. I guess give our opinions, and then I guess that can lead us into talking about the rest of the paper. By the way, did you get a chance to read this paper, Jordan?
Yeah, I did.
Oh, okay, cool. I guess before we begin, I guess what were your first thoughts on the paper? What do you think about it?
Well, it kind of high, it kind of highlighted some
Mm-hmm.
issues that I had with AGI itself. Well, not AGI
Yeah.
itself, but the general optimism that people have towards AGI.
Mm-hmm.
Uh, yeah, because I don't think that AGI itself will be solved anytime soon. But
Mm-hmm.
I recognize the strides that we're making towards it. And I think that we're making the applications of what we have now are um, potentially, what's the word I'm looking for? uh, Vast, I guess.
All right. So I mean, I guess we'll talk more about this, but I mean, do you think we are the work that's being done right now? Do you think that's making progress towards um an actual AGI system, or is it more just towards better, I guess, narrow intelligence system? So basically, better chatbots, better I don't know, self-driving cars, but not necessarily something that is generally intelligent that can basically just take up any task and do what humans do. Do you think the progress that we're making is more along the route of creating better, narrowly intelligent systems rather than working towards something that is generally intelligent?
Um, well, I think that I'm kind of in between
Mm-hmm.
because I think that some of the methods, the approaches that we're taking towards developing the narrowly intelligent systems could be applicable to general intelligence.
I see. Yeah.
Like I think self-supervision is
Mm-hmm.
going to be pretty important for a generally intelligent system,
Okay.
and um, stuff like things like um, deep. reinforcement learning.
Mm-hmm.
I think like I think a similar technique would be important to a general intelligence, but I don't think, well, personally, I don't think that any one architecture would
Yeah.
solve general intelligence. I think it would probably be some form of combination, because
Okay.
in the brain, you have different, like you have a visual cortex, and then you have a cortex to process audio,
Yeah.
and one to process the smell and stuff like that. So I think that a generally intelligent system might have to have separate components.
Yeah. So I guess you're of the view that we're essentially creating the basic subcomponents that I guess eventually we might use in this general intelligence system. All right. Yeah, I agree to in some sense. I mean, I think definitely there has been a lot of progress, as I mentioned earlier, made with like, narrowly intelligent systems. So I think in the coming years, so I know people have made predictions that, we'll have AGI in 2029. So that was a prediction made by Ray Kurzweil in his book, The Singularity. Um, yeah, so he predicted that we would have like a full-blown AGI. So just to clarify what an AGI is for people that are listening, it's essentially a computer system that has the intelligence of a human. So he predicted that in 2029 that we would have artificial general intelligence. Now, the way he came up with that prediction is basically using Moore's law. So he basically calculated, what, in terms of computation it would need to simulate the human brain. And based on Moore's law, we should have that computation, or at least the hardware side of it, by 2029. I mean, I disagree that just because, Moore's law, follows this trend of, doubling computation every 2 years, that, somehow a system that can think as intelligently as a human will somehow just magically appear. I think definitely there has to be some specific work done on, you know, creating that system like that can, do all the tasks that a human can. I mean, I feel like a lot of what's being done right now is, as you said, they're just creating these different components that are very good at these specific things. But I don't see a lot of conversation on creating an actual thing or system that would, you'd say, be as intelligent as a human, or, be able to carry out all the basic functions and things or tasks that a human can. So I definitely think there needs to be a more direct approach to solving that specific problem. If the goal is to get something by 2029, but I mean, this idea that, we're just developing these separate parts and then somehow magically in 2029, they're all just going to come together to create this, intelligent like humanoid. It's very, I think it's very unlikely. Um, I mean, honestly, there are a lot of researchers, I think even Jan LeCun, are actually kind of distancing themselves from the whole AGI concept. Like people think that, just because you've seen it in sci-fi movies, that it's something that will happen, or, has to, it's a, like it has to happen. um that it might not, like we haven't even really defined what that is. We have an idea of what we mean by artificial general intelligence, but in terms of how we would go about creating it, how we even prove that it is generally intelligent, I mean, that's something that we haven't even really thought about fully. So yeah, like, this 2029 prediction, I think it's pretty far-fetched. So what do you think by the year 2029 we will have a full AGI system?
I definitely don't think
Yes.
so.
Oh, Bennett, you're in the all right.
Sorry.
So Jordan says no. So
I
Bennett,
see that
why do you
Jordan
think
is
we will
saying
have something
yes.
by 2029?
No.
Yeah, Bennett. Um, I'm
No,
not
I
hearing you.
think I heard Jordan speaking.
Yeah, man, I was saying he said yeah, Jordan said no, he doesn't think. I guess we'll ask Jordan why he says no, and then we'll go on to Bennett and say why he thinks yes. So Jordan, why do you think no? 2029. Why won't we have AGI in 2029?
Yeah. I just think that well, AGI is a concept that we're trying to model after the human brain. And I
Mm-hmm.
don't think that you can build a system that performs as well as something that you don't understand, if you see what I'm saying.
Oh, I see. So you're saying we don't have a full understanding of how the human brain works. So
Yeah,
how can we create something that we don't even have, or model something that we don't have a full understanding of?
yeah, that's my train of thought.
Okay. All right, fair. Bennett, what do you say?
Well, we did model things like airplanes without having full understanding of
Mm-hmm. How
how
birds.
airplanes work today. Don't think there's a complete
Mm-hmm.
concept or complete understanding of what airplanes are entirely yet. Regardless of that, we have functioning airplanes. But those are fair points drawn. But one outstanding reason why I think AGI is likely by 2029, roughly then,
Mm-hmm.
that prediction was made by Rick Kurzweil, among
Mm-hmm.
others, predicting things such as the emergence of the internet before it emerged was something internet-like, and about 80 something percent of his predictions have been sound so far. So he bases these based on laws of accelerating return, which is similar to Moore's law, which states that each year computing power doubles roughly. In some cases, we see faster increments as price performance. So price decreases and performance increases each year. So that has been consistent for quite a long while now, centuries. And by 2029, we have first hardware capable of 10 to the 18 floating point operations per second in a small form factor. So we have that already called extra scale computing, but it's in the form of large warehouses now. But we're approaching smaller and smaller form factors, similar to how we saw computing went from, as in traditional computing, going from large warehouses to smaller one, to smaller computers for today. Traditional computing was basically one human-based architectures where we had central processing unit doing computation, and the newer architecture based on the brain is about distributed computation, similar to the brain, the human brain, and so on. So one
Well,
thing that we tend to underestimate
mm-hmm.
is the exponential change across various patterns. So for example, with the human was it, the Genome Project.
Mhm.
First, for most of the, for 7 years, the project took place. And for a majority of the years, only about 2% was done. But by the 7th year or so, there were so many doublings in that time that the project was complete. But before those doublings, many experts were saying that it would take hundreds of years, but simply because they underestimated the doubling power of technologies. So that is one obstacle in our thinking sometimes. We think mostly linearly, and we ignore exponential change. That's another thing Kurzweil points out. It's similar to a lily pad in the pond, the lily pad story. How long does a pond take to be filled with lily pads? In about 10 days total, the pond will be filled. But by the 5th day, the pond is only a small percentile filled. But based on some doublings, by a short time, it's full. So it's something similar to that.
All right.
So not only will hardware improve,
Mhm.
receive this doubling power, but software also will receive this doubling.
But I
So
guess
neuromorphic computing and AI software.
that's where I'm kind of, or maybe where we part ways a bit. Um, I get what you're saying about the whole law of accelerating returns. Especially with Moore's law, we see that computing power is doubling every 2 years, and Kurzweil uh, basically came up with this approximation of how much computation it would take to model the brain, about 10 to the 19 or so calculations per second, and he extrapolated that on a graph and saying by 2029 we should have equivalent um, power of the human brain on a say a computer. But the thing is, whilst I might whilst I agree that in terms of the hardware that is maybe the case, but in terms of the underlying algorithms or the, as you said, the software that we would need to create this generally intelligent system, um, do you think that we already have the basic components to create such algorithm, well, that algorithm or the final algorithm or whatever software? Do you think we understand enough about what it would take to create an AGI system? Or do you think that maybe a few years from now there's going to be some major breakthrough in terms of algorithm that sets us on this accelerating path towards AGI by 2029?
Not an AGI expert, but
Mm-hmm.
I can make some estimation.
Mm-hmm.
For example, there have been studies of the biological brain. We don't understand much about that.
Mm-hmm.
Well, we suspect our neuroscience research lacks lots of understanding, lots of work to do, lots of parts of the brain to map,
Yeah.
but we have extracted as humans a reasonable basis of how things may work overall in terms of the underlying math required. Lots of work to do.
Okay. I know you brought up this comparison with the airplane and the bird. I know a lot of people like to bring up that or draw that comparison. Back when they were making airplanes, um, we didn't need to exactly model an airplane like how a bird flew. for airplanes to work. We have airplanes today. So I guess the question to you guys is, do you think we need to have a full understanding of the brain to get AGI, or maybe we don't? Maybe is it like the airplane where we don't, it doesn't exactly have to be like the human brain, or it doesn't exactly have to work like the human brain for it to, work? Or
Excellent
do you
point.
think that we would need to first understand the human brain completely before we can even think of designing an AGI?
Well, I don't think there needs to be like necessarily a complete understanding
Mm-hmm.
because um but I think there should be some understanding of the underlying processes
Okay.
that that um the brain does probably subconsciously to some extent. Because like going back to the plane and the bird, um
Yeah.
planes don't flap their wings, but they have engines to generate the thrust that they need to generate the lift.
Mm-hmm.
So like it's not exactly the same, but because there was some understanding of the principle
Mm-hmm.
behind how birds can fly, we could approximate a process that could simulate that.
Mm. Okay.
I think
Um,
it's a we may need to, as Jordan underlined, definitely understand some underlying pieces and principles,
mm,
and it will be a reasonably harder task than understanding the principle behind aerodynamics, because this frontier is the last, often referred to as humanity's last invention. As you pointed out in one of the first meetings, AGI will be like a meta solver.
mm,
So once we create AGI, we can reasonably solve all the other, most if not all the other issues, physics, math, pretty much any cognitive task we do, self-driving and so on. So it would be a hard task to undertake, but both hardware and software are reasonably exponentially evolving, and we should try not to discount
mm-hmm.
potential change, because it only takes a couple of doublings at a certain point
Yeah.
to get to the the breakthrough points
All
with
right.
venture to human level AI.
So so I guess from here we can, I guess, um go into talking about maybe the dangers and benefits of making predictions. So a big thing in this paper is, she talks a lot about the different AI, summers and winters, or springs and winters, sorry. And she basically mentions how, there has been a lot of predictions throughout the years, and the AI winters resulted from people making unrealistic expectation, or having unrealistic expectations about the promise of AI. So, for example, I think she stated that in about the 60s, people thought we would have, intelligent like robots. People had the same idea in like the 70s or the 80s. So basically, with every AI winter, there was a corresponding sort of hype, or, some unrealistic expectations as to the promise of AI in the future, because of essentially, the sort of results that were going on at the time. They thought that, this would just progress, or whatever method they were using at that time, it would eventually lead to the intelligent systems that we talk about. So for example, I think in the 60s there were things like expert systems and stuff like that. People thought that was the right approach towards AI systems. I guess that didn't pan out to be the case. And now we have, neural networks and stuff like that. I guess the question to you guys is, do you think there's a danger to making these, or, a danger to having these sort of expectations or unrealistic predictions? Well, I'm not going to say it's unrealistic because we don't know if it's realistic unless the time comes and we can see whether it happens or not. But do you think there's some danger in, maybe promising too much too early? What do you guys think? Do you think that, making certain predictions could maybe lead into us having another AI winter? Or do you guys think we will have another AI winter?
I don't think there'll be another AI winter because of how embedded AI is in society right now.
Okay.
Because like you have so much of Facebook, so much of like social media platforms like Facebook runs on AI algorithms, like Google Photos, like you can search by faces and all of that. So I don't think there'd be another AI winter, but there might be some form of like decreased funding because like if investors are expecting like self-driving cars 5 years ago, or I mean 2 years ago, or so, because I think Elon Musk promised it by the end of 2020 or something like that. And they don't have it by like 2025, then they'd naturally start looking for more promising ventures to invest in. But I don't think there would be another AI winter. I expect it to be a pretty dominant domain in computer science.
Okay. So what about you, Bennett? Do you think there is some danger to making these sort of predictions in terms of?
I think the AGI prediction by 2029 is a bit separate from last hype. AI hype now. Hype can hurt by how can AI hype hurt? What types of AI hype are going on now? Some people are labeling things as AI that are not AI. So for example, there have been cases where companies have humans working on some tasks and claim that AI is working. And when the news breaks out, sometimes this can hurt investment into AI education and infrastructure construction. So in that sense, hype hurts. But I detect or estimate that the 2029 prediction by Kurzweil is a reasonable one. And one other issue I have with this paper, I noticed that there, unless I'm mistaken, 0 equations or mathematical frameworks there. So I can't exactly determine or precisely determine whether Melanie's estimates are entirely reasonable.
Well, I don't think Melanie is making any estimates. She's just more, I guess, doing a survey of the field of AI in general, and basically looking at the results versus the expectations. And I guess she's more saying that, throughout history, we've been making a lot of predictions as to what should be or could be at any point in time, and the results have come up short in a lot of ways. And that maybe, what we consider AI might be a lot harder to achieve than we first thought. And I guess she's looking at, different points in history where people thought we would have had certain things by now, but I guess didn't pan out, or it didn't pan out that way.
Yes,
Um,
it's a hard task.
yeah.
I think that since man began, there have always been misestimation.
Mm-hmm.
But while that is true, we've also seen a consistent path of exponential change in
Okay.
computing power, in AI software as well as AI hardware, otherwise known as neuromorphic computing. So while
Right.
there are misestimations, and some of those misestimations can be attributed to a lack of understanding
Mm-hmm.
of things like, for example, the total capacity or synaptic operation per second of the human brain. So, for example, in the along the days of the AI winter, we may have mischaracterized the back then hardware capacity
Mm-hmm.
compared to the capacity of the brain, and so came up with unreasonable expectation. So one reason why I'm skept- quite skeptical of the paper as well, Melanie's paper. So for example, policy what she makes, she lists some policies. She says policy one, narrow intelligence is on a continuum with general intelligence.
Yeah.
While that may be valid in many cases, I'm not seeing any justification, any precise justification to strongly posit that that fallacy exists. So,
Okay.
for example, the current backprop basis of most deep learning systems today,
Mm-hmm.
or differentiable programming, as the undertone calls it, is expected by all these experts to be the on a continuum with general intelligence, contrary to what Melanie lists here as a fallacy.
Even though there has been no proof or evidence that the brain doesn't do any form of back propagation.
Yet there has actually been evidence. Maybe I could cite a paper now. The brain does something looking like backprop.
Okay.
I think DeepMind was involved. I'm not sure.
All right. I mean, I think you raised a good point. I guess which brings us into the next part of this paper, where she um talks about the different fallacies. I guess with AI predictions. One thing I like that she brought up um was the whole fact that, and I guess this comes into the whole hype debate with the AI. They're especially with companies and profits and media releases. A lot of companies these days release these big news headlines that we've done X and we've done Y. But when as time goes by, and we look at it, we realize that it wasn't as special as it seemed to have been at the time. So I mean, do you guys think that with a lot of these releases that these companies make in terms of some new result or some new benchmark that was beaten or whatever, do you think like a lot of it is just more hype than actual substance? Um, all right, let me, I guess, use some examples. So, for example, when Deep Blue beat Kasparov, in the game of chess, a lot of people were like, "Wow, this is some big achievement. We're so much closer now to machines that can think like humans." But as time goes on, realize that that deep blue system, was fairly simple in terms of how it went about making the moves and stuff like that. It it basically wasn't doing it like how a human would, but at the time people were like all crazy about it. Or even looking at something like the AlphaGo system, again, there was this big hype around it, and people were like, wow, people never thought this could have happened. But again, when you look at the actual system, um, again, it's not as special as people think. Um, it's very controlled environments, a deterministic game. Um, you know, so I guess my question to you guys is: do you think that there is, I guess, more hype than substance with a lot of these press releases nowadays?
In some cases, I think so. Because I've read, well, so a lot of the papers that I've read, um, it seems to be like very incremental work that's done.
Yeah.
Like you'll see a paper, go fork the source code on GitHub and play around with the hyperparameters a bit till they get an extra 0.5% or extra 1 or 2% on the benchmark. So in terms of those, I think that those types of results might be more hype than substance, but I do think that there are some things that like the hype is worth it, I guess.
Okay. Before we continue, the meeting time is about to run out. So if at any time you see it like it quits, just click back on the link and it will, I guess, bring it back into the meeting. All right. So yeah. So another point she raises is the whole thing about the second fallacy here. Easy things are easy, hard things are hard. So a lot of the things that we thought would have been hard for a machine to replicate, it's like playing chess or playing Go. Because for us humans, that seems like, well, it is a complex task. I mean, not everybody can play chess at a certain level. Not everybody can play Go at a certain level. But yet we were able to. Yeah, can you hear me?
I can.
Okay. Yeah, so back to what I was saying. So yeah, basically, um, things like playing chess or playing Go, things that we as humans see as complex tasks, that maybe only geniuses or smart people can do. Well, like you think that, intuitively that would translate into um, creating or creating systems that can simulate those tasks, right? So you think that it would be just as hard to create a computer program that can beat the best player at chess or beat the best player at Go. But we've seen time and time again where we've actually created programs that beat the top chess player, beat the top Go player, beat the top players at Jeopardy. All things that we as humans see as things that are generally complex, hard, or whatever. But it turns out there's this sort of paradox where the things that we as humans see generally as hard turns out to be a lot easier for us to create machines that can simulate those tasks. But the things that we as humans find easy, something like walking, something like being able to see and perceive the world, that turns out to be the hard thing or the hard task. It's easy for us humans to do, So it's easy for us humans to walk, or it's easy for us humans to see, to hear, generally to do our everyday tasks. But if you ask a human to, exactly describe, you know, from a biological point of view, how we go about doing all of those tasks in detail, it's hard to see how you can come up with a full description of that. So I guess the question here is, do you think because that paradox exists, where the so-called easy tasks are not as hard, well, let me say, the tasks that we thought would have been easy seem to be a lot harder? Do you think because that paradox exists that maybe our predictions of, general intelligence might be way off? Or, do you think that there's some sort of reason why that paradox exists? Why is it that the tasks that we as humans, see as complex or hard, it seems that we've been finding that easier to replicate on a machine, but the tasks that we find easier to do on a daily basis, like seeing, walking, hearing, something like even picking up a bottle or something like that off the ground, that seems to be a lot more challenging. Like, why do you guys think that paradox exists?
Well, I think our bodies have evolved to like like through evolution, our bodies were optimized for tasks like vision and movement and stuff like that. Because like before any industrialization happened, when we had to be hunting and all of that, I guess our senses would have been more important, like vision and smell and all of those things would have been more important. And so in comparison, games like chess have only been around for a much shorter time relative to the amount of time humans have been around. And it's not something that our brains would have optimized for. And also I think that the whole act of chess, like it's a pretty deterministic game. Like there are a finite amount of moves and all of that, and there are patterns that you can take to win. So I think tasks like that computers are really suited for.
So if that's the case, then do you think maybe that we're using the wrong benchmarks then for AI progress? Because it seems that throughout the years we've been using these sort of games, the chess, the Go, as these benchmarks for how well we're progressing in AI. Do you think that maybe we are going to have to pick better benchmarks for tracking progress of artificial intelligence, or towards the goal of AGI?
I think the only I'm not sure. The only real benchmark that I guess is there for an AGI system might be like a Turing test kind of thing. Like if it can pass a Turing test, because I don't know if we can define another benchmark apart from when it's indistinguishable from a human.
And there has been a lot of debates around the Turing test and the validity of the Turing test. Does it machine, if it's able to pass the Turing test, does that mean it's really intelligent or generally intelligent? For those who don't know, the Turing test is basically a human interrogator asks computer a bunch of questions. If it's unable to distinguish whether it's a human or a machine answering the questions, then the machine would have passed the Turing test. I mean, we've seen where, there are a lot of chatbots that, they sort of fake, how a human would. I know there's a chatbot called, what's the name of it? It has like a Japanese name. Um, yeah, but there's this chatbot that it sort of kind of fakes human responses. So, we humans, we wouldn't respond as how a computer responds. So our speech is kind of very, haphazard at times, or, it involves a lot of emotion and stuff like that. So, a machine could, pretty much, or let's just put it this way. In the future, machines could get better and better at simulating that sort of human-like response. But just because it's getting better and better at simulating that sort of human-like response, does that mean it's actually intelligent? Does that mean that it's actually understanding what it's saying? Does that mean it has, consciousness or whatever? I guess that, yeah.
Oh, sorry. When I said Turing test, I didn't mean the Turing test specifically. I just meant like a similar benchmark by which like you validate the AI system against a human.
Mm-hmm. Yeah, I get it. I get it. I mean, I personally think that, a lot of the press releases around, these AI discoveries, or, these big new systems that, do, some, some by some metric, like some percentage points, beats the new bit the score at some benchmark or whatever. I think there's a lot of hype involved in those press releases. As I think those, especially with the AI systems nowadays, it's I think it's easy for those systems to pass or do well in those benchmarks without actually solving the task. I think just because something, um, does better at some sort of benchmark doesn't necessarily mean that it's doing the task any better. Doesn't necessarily mean that it's actually understanding the task or whatever. The data that they use for the benchmarks, it could be finding some way to do that specific date, or basically it might be finding some way to do well on that specific data set. So like, for example, the ImageNet data set, or some other data set that's been used time and time again. Just because you're getting a higher accuracy point on the ImageNet data set, I don't think necessarily means that you have a better vision system. Doesn't necessarily mean you have something that is better at understanding the world or anything like that. I think you definitely need benchmarks that look at that specifically or directly. But yeah. What was I gonna say next? Yeah, I guess from here, yeah, I guess one question that has been, I guess, puzzling me lately is the whole, the conversation of consciousness versus intelligence. Do you guys think that we would need to answer the question of what is consciousness before we can create something that is, I guess you could say, generally intelligent? Or do you think that we will need to answer the question of what is consciousness before we can create an AGI system? Do you think that intelligence requires consciousness, or general intelligence requires consciousness? Or in your opinion, what do you think consciousness is? Like, what is consciousness really?
I think we'll build AGI first. We'll
Mm-hmm.
use AGI to help answer
So
those questions.
you think we need AGI before we can answer? So you think we can create AGI before we figure out what figure out consciousness, essentially.
Yes, I think we may not be smart enough to uncover whatever
Mm.
that is.
Okay.
I think we need the help of AGI to augment our own investigative path
So
because we
you
lack the nuance required.
so you don't think consciousness is a necessary precursor towards intelligence?
I'm not even sure what it is.
Yeah. Okay. Yeah. Good point. I mean, I'm not sure either, but I mean, there's definitely, you know, in terms of how humans think versus, yeah, I mean, this is a big debate because I mean, some people say that, only humans display consciousness, while other people say that consciousness exists on a spectrum. So consciousness exists in everything,
Or
but
like
in just
Tononian.
different levels.
Tononian was, I think he had a theory, I don't know what the theory is called, integrated theory of intelligence, I think, or
Hmm.
consciousness, where there's some 5 level of consciousness across various things.
Yeah. So Jordan, what do you think? Do you think we don't need to answer the question of consciousness before we create an AGI system, or do you think that consciousness is a necessary precursor to some general intelligence? So before we can
Uh,
create a intelligence that's on par with humans, then it must also be conscious. Or yeah.
um, well, my understanding of consciousness itself, um, it's kind of, to me, it seems like an awareness of,
Yeah.
like a self-awareness kind of
So
thing.
mm-hmm.
Um, and I think that I don't think that consciousness and intelligence and general intelligence, at least the way we think about it, are
Mm-hmm.
mutually exclusive. I think
Okay.
that if you have a generally intelligent system, then it would probably be conscious by extension.
Oh, I see. So you're saying consciousness is emergent from intelligence, not the other way around, or
I
from high
think so.
intelligence or general.
I
Okay.
think so. I think so.
All right. I guess we'll touch on 2 last points and then we can end this tonight. You mentioned earlier that, why when we're discussing Marvet's paradox, the whole thing about the easy things being hard. And you mentioned the whole thing about, evolution and, our DNA encoding knowledge that we would have learned, through many years. If that's the case, do you think that maybe then, that, whatever approach we come up with for creating a general intelligence system, it will need to involve some sort of evolutionary sort of programming, where we have systems that are over several generations, getting better and better, and that produces offsprings of better and better systems that somehow spawn some general intelligence. I guess the question I'm asking is, do you think that you know creating general intelligence will be something that is, I don't know if this is the right word, purposefully done, or will it be something that is emergent from some process? Like, do you think it's something that, just imagine like an engineer, designing the system and putting the nuts and bolts in the various parts, and then that's the AGI system? Or is it something where you kind of have this starting process, and then, through some sort of evolutionary programming, it eventually, after several iterations, some sort of intelligence emerges from that? What do you guys think about those 2 approaches, and which one do you think is most likely to lead to a general intelligence system?
You code a starting process, a basis, and then something will emerge. Because even now, for example, a self-driving system, convolutional neural networks, they learn billions and billions of parameters. No human being can sit down to pass those numbers, those learned numbers. So what is happening is that we call a smart basis, which then learns the parameters, and general intelligence will maybe be a learned sequence of parameters that no human can or could have sat down to purposefully, almost wholly assemble or prepare. So it would reasonably be some starting basis that learns to become a general learner.
All right, Jordan, what do you think? Do you think that AGI is something that's going to be emergent from some simple evolutionary process, or is it something that we're just going to have to plan out exactly what components we're going to need to do this, that, put the parts together, and then we'll have our general intelligence? Or do you think it's something that will just sort of emerge from some iterative evolutionary process, or some learning, sort of like how we have now, where it's kind of learning some either through gradient descent or something like that, sort of encoding the knowledge in its parameters, and then eventually from that some intelligence emerges?
I'm not sure, because I think the way that we train AI systems now can be thought of as evolutionary in a sense, because like with each epoch, we save the model's weights and then we back propagate through them to figure out what's the error, like the amount of error that's being produced at the output and all of that, and how much you should adjust them. And then it takes those saved weights and uses them as the starting weights for the next epoch. So, I mean, in some ways, I think that the approach that we take now is evolutionary. But I think the typical training, I feel like an AGI system would have to be trained for a lot longer than current systems might be trained for. I guess I'm not sure how to word it, but
yeah. All right. Ben, I think I saw you raised your hand or something like that. I don't know if you wanted to say something else.
Seems to be an accident.
Oh, okay. All right. So the last. Oh, you were saying something?
No, go ahead, please.
Yeah. So I guess the last thing we can end on is the last point this person was making in the paper, or the point that kind of jumped out at me. So she mentioned the whole thing about embodied intelligence, and I know a lot of people are working on this particular area. Do you think that to create an AGI system, it will require us to create sort of like a human-like form, or do you think it's going to require sort of like a human-like apparatus or machinery so that it can interact with the world as how we do for it to become generally intelligent? Or do you think that it can be the apparatus doesn't matter? So like it can be in a computer or just on the internet. It doesn't have to be in an actual physical robot that has to interact with the world and sort of learn the sort of underlying physics of the world and stuff like that. Do you think that A, it's necessary, or B, it's not necessary? Do you think that an AGI system is going to need a body? I guess that's a simple way of putting it.
Well, I'm not sure if it's necessary, but
Mm-hmm.
like, if we're modeling AGI off of humans,
Yeah.
then like a fundamental part of what makes us humans is that we can interact with the world around us.
Mm-hmm. All right. What do you think, Bennet?
I'm not too sure, but I would align with Jordan's answer there. There must be a way, well, there reasonably should be a way to perceive stimuli and data
Yeah.
to form some sort of backprop like process, some process for error correction or
Mm-hmm.
error minimization in whatever data structure is used to facilitate learning. So it may not need to be a robot body, but some form which facilitates this feedback loop.
Okay. All right. So I guess we'll just end by, I guess, throwing out this question. So what year do you think we will have? Well, I'll ask two questions. First, do you think that AGI is possible? Number two, if it is, or if you do think it's possible, what year do you think we'll see an AGI system? So I guess I'll ask each of you. Jordan, you can go first. So firstly, do you think AGI is possible? Do you think we will eventually create a generally intelligent system or something on the same intelligence level as a human?
I think AGI is possible, but I don't know how to predict like when it would happen. I
Okay.
Yeah.
So do you think in the next 10, 15, 20, or
Uh
maybe a lot
I
further?
think it would. I don't. I try not to be optimistic when I say stuff like this. So
Yeah.
maybe maybe uh sometime over the course of like a lifetime, I guess within the next 50 years or so, maybe.
Okay. All
But
right. So probably around 2070, 2060, 2070.
yeah, maybe. Because I don't think the hardware itself would be a problem.
Yeah.
I think we'd have the hardware for AGI a long time before we have the software for it.
I see, I see. So Bennett, what do you think?
One, we're made of clumps of atoms
Mm-hmm.
whose configuration has been raised to general AI. And given that we're organic clumps, there's no law of physics that forbids the emergence of something looking like general AI, inorganic clumps or configuration, namely in silico. So from that scope, AGI is reasonably possible.
Okay.
It's a matter of the substrate, where organic substrate, and there's no law of physics, or rather, physics indicates recently that the other substrates that can give rise. And on the prediction,
Mm-hmm.
roughly by 2029, as
2020.
predicted by Kurzweil. So not only that hardware will tend to this 18 floating point operation per second,
Mm-hmm.
but also the software. So we'll have both hardware and software change in an exponential direction, unless we destroy ourselves first, or there's some super bug.
Yeah. Well, I guess I'll ask you a follow-up question. Do you think the current substrate that we're using, the whole von Neumann architecture, silicon chips and all of that stuff, do you think that is Do you think an AGI can work on that, or is it gonna require something new? Or is it gonna have to work on quantum computers, or or some new architecture we haven't even thought of it, or something more like wetware? What do you think?
I think it will be on quantum neuromorphic systems.
Mm,
So we're already building things like neuromorphic computers.
yeah.
In the just Nano I bought 2 years ago or so, that is a neuromorphic computer. But I
And
think
then
it will be quantum
mm,
to facilitate the number of operations per second.
okay,
In the von Neumann architecture, it will probably be too expensive to compute.
I see.
So if we don't, even if we don't do quantum, it will be
Mm-hmm.
neuromorphic. It should not necessarily quantum. Quantum could afford maybe something like super intelligence beyond
Mm,
general intelligence.
okay. All right. Well, I guess for me, is AGI possible? Um, I think we will create something that is on the level of human-like intelligence for sure. But will it be exactly like a human in terms of how it thinks, and you know the ability to be self-aware, and question things, and wonder why it's in the world, in terms of creativity and stuff like that. I'm still on the fence about that. I mean, I think there are still questions about the human mind in itself that we would need to answer before we can even think about predicting that. But I mean, if you're talking about something that generally can do tasks that a human can do, if we're talking about general like an automaton, something that can, you know, drive a car, or walk from place X to place Y, pick up objects, have an intelligent conversation, then yes, I think that's definitely possible. In terms of when, um, uh, for me, definitely not 10 years from now. Well, where are we now? 2021, so that's 8 years. Yeah, definitely. I don't think 8 years from now. Even though I do agree with the whole thing about off accelerating returns, but I'd give it another, say, 20 years. So maybe by, say, 2040, that we probably will have something like that. But I'm hoping that it's earlier. I guess everybody's hoping it's earlier, but we'll see. Yeah, I think that concludes the discussion. Um, yeah, I think this is a pretty good discussion. Um, I guess Jordan, you're gonna have to tell us about your crypto synth. How is that going, by the way? I know you put up some stuff on like NFT marketplace. Have you been getting any buy-ins for your crypto synth? Um, Bennet?
Yes, I
Yeah.
actually got 6 or 7 sales so far.
Okay.
But
So
I
I'm
don't
I'm
advise. Sorry.
yeah, I was gonna just ask about I know you say you can have like conversations with it, like, in terms of conversation, like what sort of, yeah, is it like a typical chatbot type conversation,
Yes,
or okay.
mostly typical. What I did was to convert. We start from an AI generated picture of a fake person, but it looks
Mm-hmm.
real from style gun. Then
Mm-hmm.
I converted that to a realistic looking 3D model.
Oh,
Then
I
I
see.
took that and rendered that in Blender. But I also modified or created a plugin
Mm-hmm.
to facilitate the integration of Python GPT-2 into Blender.
Okay.
So now they interact with the synth through a cryptosynth dialog, which is just basically a text box. The user
Mm-hmm.
supplies a message,
Yeah.
The scene then animates subtly. The eyes go left to right, from left to right,
Mm-hmm.
pretending to read the text, and then activates GPT-2
Mm-hmm.
to return an informed response or intelligible response based on the input. So that's
All right.
the conversation for now. But in further versions,
Mm-hmm.
I plan to have the vision systems that perceive the user's input, user's face, I should say, detect emotions, and also emote. The synth itself will also emote, so create dynamic facial responses beyond the pretend to read action and the dialogue output. But that would require a bigger computer to do.
All right. Cool stuff. All right. So I guess we're kind of over time, but I think we had this was a really good discussion. Um, yeah, I like this sort of format where we're kind of going through a paper and we're kind of asking different questions, or discussing different points about it. Like when we can have these sort of probing conversations about certain things. Is definitely something we should have more of. But yeah, thanks for coming. I guess next week maybe. Guess we can try come up with or if we come up with another topic or another paper that seems interesting, then maybe we can talk about that as well.
Excellent.
But yeah. All right, guys. I guess good night.
Thanks for organizing.
See you next week. All right, no problem. All right, bye, guys.